Hey robot makers, this is a video of me making the Kev's Arcade. The first task is to solder up a couple of buttons. There are 4 buttons in total that we'll be soldering up, 2 for the A and B buttons and 2 black ones for the select and start buttons. There's actually a 5th button which is the joypad controller, but that's not something we need to solder up. Now I could have got some spade connectors to connect to these arcade buttons, but instead I decided to use just some DuPont cables. One of the tips I found as well is if you have a good mechanical connection with your soldering, that also means you'll get a good solder connection. So that's the black buttons done, just checking that the soldering is a good connection. They work pretty reliably, these things. And there's one of the yellow buttons, and there's also a green button as well. This is the KY23 joystick, and you can see here I've been cutting out some of the pieces that make up the arcade cabinets. This is a 5-watt Creality laser cutter. So I've got all the pieces cut out now, and I'm simply going to start assembling together the pieces. I usually like to do a dry fit first of all before I start putting any glue together, just in case there's anything I haven't spotted, and it can also help just make sure that the sequence of putting these together also makes sense. You can see there how it's going to look. And it's a very simple tab and slot design. I've also made it so you can actually remove the Raspberry Pi and the screen just by using those screws at the back. You can see there as well there is 2 pieces that make up each side, and that's just to give it a bit of strength and thickness. It's only 2mm basswood that I'm using for this. This is actually the second arcade cabinet I've designed, and this version has these 2 front buttons. I didn't realise when I built the original one that you would definitely need to have a start and select button to use with RetroPie. So this is the control panel piece, and you can see there's the little joypad, and we're just putting in these standoffs so that it gives it a bit of depth and presents just at the right place without showing the user any of the electronics beneath. So it does require just 3 screws on this one. I found that if you put the 4th screw at the top right, the joypad wouldn't actually turn properly, so I'm not sure why they designed it in that way, but that little circuit you can see dangling at the back there, that's a Raspberry Pi Pico, and that helps us take the control inputs and convert them to USB so that the Raspberry Pi can have that as just a USB input, and it sees it as a gamepad. This is the speaker grill section, and then the very front piece, I think they call that the carousel, that's also going in place. So that's the dry fit complete. There are all the different pieces, how it's going to go together. The next step is to apply some glue to each of them. So the 2 pieces that make up each side will need to be glued together. So I've just got this Gorilla wood glue. It dries pretty quickly in about 30 minutes. This first one I didn't do a fantastic job of putting all the glue to the edges, but on the second piece you'll see that I used my finger to smooth it out a little bit. It just stops all this squish happening and all the glue coming out the joints. I've got these nice little handy clamps. I've got 6 of these in total. I just need to make sure at each point, as I'm putting the clamps on, they don't move it sideways. So we need to make sure all those slots align correctly. So once the glue has cured, we can then remove these and do the next piece. It's just essentially the same but without that hole for the Raspberry Pi pinouts. So on this one I did the job a little bit better, so there isn't too much glue at the edges, but it does go all the way to the edge. A bit like buttering a sandwich. So once again, 30 minutes later, that's cured and we can start gluing all the rest of the pieces. Now I did find with the very first one that I did, it's easier to build one side first in totality and then put the last side on to stick everything together. And that gives it a lot of strength and it's just easier to work with. So you can see there the last piece that goes on is the left side. But it is a little bit of a fiddly task. You've got to keep adjusting each of the pieces, each of the slots to go in, and they do have a habit of just falling out there. So there we go. So in 30 minutes time we'll be ready to clear it off, clean off any of the glue, and see which is what I'm doing there. And then we can start painting it. I'm just using a wet wipe to get rid of any glue. So this is a simple black acrylic paint, and it actually only took 1 coat of paint to do the entire thing. It was extremely satisfying to paint this, I've got to say. So that's the first side done. Next is the control plate. And then we've kind of whizzed ahead a little bit here. You can just see me finishing off the speaker grill. And there's the front panel where the two new buttons are going to go. Now, because it's made of basswood and it's only 2mm thick in most places, it's incredibly light. So you can see it's very easy to handle and paint. I tried my best to avoid painting over any of the Raspberry Pi connectors. So next up, it's the electronics. So I bought a brand new Raspberry Pi. I think this is the 2 gig version. We don't need an awful lot of RAM for doing the emulation, but we've got the speed of the Raspberry Pi 5. I've also got the active cooler there as well. That's a little fan that just sits on top of all the 3 main chips, well, 4 main chips, and gets rid of any of the heat. There's these little spring-loaded connectors you just push through the board, and they just hold it in place. And then there's a tiny little connector for the fan. There we go, that's all done. Next up is the officially branded Raspberry Pi. This is a 64 gig SD card. And I've also got these really nice Hyperpixel 4 displays from Pimoroni. I think I bought the last of the remaining stock of these. So that's a little extender for the GPIO pins. And here's some of the standoffs as well. Here's the display itself. So this is an 800 by 450 pixels. Now, it's important not to push down on the screen itself when you're pushing this onto the GPIO pins. Just use the little edge. So this just helps give some rigidity and stops it moving around potentially on any of the GPIO pins. It fits just nicely above the fan. So they can just fit just in place on top of those slots. The reason I designed these as slots, originally I had screw holes, but I think I printed out 2 different versions before I'd settled on just creating a slot where we could just move it backwards and forwards. These buttons just push into place. I think they're a 30mm diameter hole, and then we've got the same for the select and start buttons as well. There is actually supposed to be a black piece that goes just in front of that control plate, but I've missed that one off. So this is the Raspberry Pi Pico. I'm just pushing in all the connectors from the buttons. The buttons simply have one active GPIO pin and the other pin goes to ground. And luckily the Raspberry Pi has a number of ground pins. So next up is to configure the software. So I'm plugging in a keyboard and mouse, a network cable, a HDMI video, and also some power. And I've connected to this already, so I can install the Raspberry Pi Connect, and that means I can connect to it from any web browser from anywhere in the world. So I'm just checking out here what are the specific commands I need to type in or boot files I need to change to get the Hyperpixel 4 display to work. So you can see there we've got some instructions on Pimoroni's website, and the config.txt file that now lives in the boot firmware folder. So we just need to add those extra lines in so that it can detect it, and we can also just switch off I2C as well. Next up, to install RetroPie, we need to do a couple of prerequisites. I'm just pasting these in from the RetroPie website, and then we need to clone the repository. Technically it's not supported on the Raspberry Pi 64-bit operating system, the latest version as well, so we have to compile this from the source. It takes about 90 minutes or so to do that on the Raspberry Pi 5. So we'll leave that going once we've just gone through the initial setup. Forgot to include the sudo command there. So there you go, it says it's not formally supported yet, but we can still go ahead and install the basic packages. So I'm just going to say yes to that, and then let it compile. Next up, I wanted to design some artwork for the sides of the cabinets, so I used Illustrator to come up with some nice designs, and I took the DXE files from Fusion 360 so that we can make sure it definitely fits. So this is a print and cut. I'm using a Cricut to do some cutting out of these pieces of artwork, which is nice, and then it's just a matter of sticking these on the side. There's one for the left side and one for the right side. You can see now that's what they look like, and yes, it does indeed run Doom. With it being so small, it's actually quite hard to film and play at the same time. So Alex helped me out do some footage of her playing Sonic the Hedgehog. You can see our Chihuahua's watching on there. I think he fancies having a play as well. He's much better at it than Alex. So I hope you enjoyed this short video, and I shall see you next time. Bye for now.